Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm talking to Tulika Bhatt about her experiences working on large-scale data processing at Netflix and her insights on the future trajectory of the supporting technologies. So, Tulika, can you start by introducing yourself?
Sure. Hey everyone, I'm Tulika and I'm currently a senior software engineer at Netflix and I work in the impression space, basically creating data services and data sets that power the impressions work at Netflix. Before that, I used to work at BlackRock and I worked on a lot of mission critical financial applications, and towards the end I was working on data science platform, and I also spent some time in Verizon building self-serve applications.
And do you remember how you first got started working in data and what it is about the space that keeps you interested?
I would say that I kind of accidentally ventured into data. It wasn't very intentional start, but then every role sort of brought me closer and closer to data engineering. So, for example, in BlackRock, I worked in a variety of different teams and roles. And towards the end, I started working on a data science platform too. So it was just creating customized Jupyter notebooks and cron jobs for data scientists, and creating those libraries where they could access data easily without having to figure out the behind the scenes infrastructure issue with that. And that project went very well at BlackRock, and we decided to sort of sell it outside. Then there was this idea of creating a usage based billing system, which would create events, and you would process and crunch those events to generate bills. So I felt like that was sort of more moving towards data. I was eventually creating those, modeling those events, creating events, and then sort of crunching them and generating bills. And I enjoyed my work, but I wanted to do something with really large scale systems, and I got the opportunity to work at Netflix, and I jumped at it, and yeah, I'm here now, sort of working in the impression space.
With the focus on impressions, obviously that's a very specific category of data. And Netflix as an organization is very large, has a very disparate set of data processing systems, various requirements around those different systems. I'm wondering if you can give some framing about the characteristics of the platforms that you're building and some of the requirements as far as latency, uptime, et cetera, and how that frames the ways that you think about the work to be done.
Sure. So I'll first of all define impression so that we are on the same page. So when you log into Netflix, you see home pages, and it creates you see a bunch of images on the home pages. So we call those images impressions, and those are sort of gateway of you discovering the product and interacting with it, and eventually leading to plays. So as you see, impressions are really fundamental for discovery. So it's a really important data set at Netflix. So we use this piece of data in variety of forms. We use it for personalization. So to see which content are you or impression are you interacting with, and it's leading to plays, that gives us a signal. Okay, these are the contents that you like. Then we also use it for actually constructing the homepage. So it's sort of using a variety of purposes of business use case of how a homepage is created. So as you can hear about these use cases, it's kind of fairly clear that you need it both in the batch world as well as in the online services. So if you're creating homepages, obviously the latency has to be as low as possible. It has to be real time. For we also like create like aggregated data sets on impressions for like a variety of personalization and like model training use cases.
Working on large scale systems, there are numerous technologies that have been built specifically for high speed, high volume. I'm thinking in particular about the Kafkas and Flinks of the world. I'm wondering, with the requirements around the type of data that you're working with, the speed at which it's coming through, and the latencies at which you're trying to deliver actionable insights to the downstream consumers, how much of the technology that you're working with are you able to pull off the shelf from whether open source projects or commercial projects versus having to think about it from a greenfield, architecture design principles of this is what I need to do, these are the primitives that I need to be able to build from, and because I have a very bespoke need, I need to build a custom system, and what the gradations are along those axes of just pull it off the shelf to build something from whole cloth.
Yeah, so I think, whenever we are evaluating like technology, obviously it's like the first decision is like, whether you're gonna get it from like something from open source, or do you need to build as much as possible. I think the first step we do is we evaluate like, if there is already a solution available. So like, for most purposes, like, Spark or like, Flink or Kafka is kind of like very good at what they're doing. So we don't just go about and like reinvent like those things again. We just use them like for their purposes. But there might be certain like use cases where we are hitting the boundaries, and then we need to some think of like customized solution in order to achieve that. For example, there was this one use case where like I was crunching something using Spark and Iceberg, and then I wanted to populate it to online data store like Cassandra. And that was something which is like there was just no tooling available for us to just do it directly. And just you could write a script going through like all the rows, and like and like just batching it and writing it to the Cassandra front row directly. But it was just like impossible to kind of like tune scale. It took a lot of time. So, and it would overwhelm Cassandra a lot and wasn't working. So they kind of work with the platform team, and they built this custom off the shelf solution of actually like taking the data in Iceberg and just converting it to SST files, and just directly sort of like copying that in. Actually, we didn't eventually send that in Cassandra. We ended up in like copying that in DB and serving the online use case. But that was something which was like there was no sort of like direct tooling available, so we had to be a little bit creative about what needs to be done and solve this particular problem.
One of the benefits that you get by leaning on existing tools such as Spark, Flink, etc., is that they have had a lot of investment from the broader community, particularly around things like deployment, observability, being able to pull together different components that are designed for various use cases. Whereas the benefit that you get from building custom is that you're able to design it specifically to suit your need. You don't have to worry about bringing in a whole bunch of extra functionality that's just dead weight and extra complexity for the problem you're trying to solve. And obviously, when you're at a company like Netflix, you have enough resources to be able to invest in custom development, but you also don't have infinite time. And I'm wondering, at least within your team, what the general heuristic is as far as the build versus buy, and how far you're willing to push one of these off the shelf systems before you decide that you actually need to split out from that and build something on your own, or build some additional component that uh, solves the need that you want within that framework.
So I think this is a really interesting question. There's always this talk about build versus buy. So like I said, like for most of the use cases, we first evaluate like how much we can push the original like solution which is out there, the open source one. we do have a flavor of like Spark inside, but it has like, some sort of like, it's not exactly the open source Spark. It has like, there's a platform team which is kind of like wrapping our requirements, our needs over it. So which is like solving all our authentication and other like, problems. So you don't have to do everything from scratch. Then I think I'm extremely lucky working at Netflix because it always kind of like, it's a place where you can always sort of like innovate. There's no there's always a like, it's very open innovation culture. So if you feel like, there is a better solution out there, and you believe in it. So at Netflix, I think we are very like, eager to actually experiment something, and kind of like build something on our own if we feel that it suits our need. So, and this I feel is different is because like, in a lot of other like, companies, that there's not that much freedom to actually sort of like, innovate. You kind of have to be within like, company sanctioned like technologies or something. So I don't know if I answered your question.
No, that's definitely helpful. And another aspect of that problem is that in order to be able to even have an informed decision about when and whether to break away from the existing frameworks, is that you have to have enough domain knowledge about the problem space, about the technologies, and about the core primitives and software principles about how these systems work, which obviously requires a lot of experience and on the job learning, as well as whatever education you have coming into it. And well, it's definitely very possible to become an expert in Spark or in Flink because of the resources that are available. It's much more complicated to get that breadth of knowledge, and it's not something that you necessarily have a roadmap to go down to say, okay, these are all of the things I need to know and these are how I obtain all of them. It's usually a very ad hoc experience. And from your career path and your experiences of working at BlackRock and now at Netflix and Verizon prior to BlackRock, what do you see as the opportunities for that learning that have been most useful, and some of the ways that you've had to stretch your knowledge and gain new skills in order to be able to tackle these problems as they arise, and just some of the challenge that that poses as an engineer to be able to have that breadth and depth of understanding?
Yeah, definitely. I feel like, working in the software world is just like, immense. It's just like ocean of knowledge. You cannot just be like claim to be an expert of anything because there's just so much out there that you don't know. So, like for example, while I was working at BlackRock, and we were sort of like, that I'm experimenting with Kubernetes, I feel like, having a good breadth of foundational knowledge is good. I feel like so for example, if you're evaluating which cloud native technology to use or which database to use, I think having the foundational knowledge of like, how this database works, what are its like, positives, negatives, what is your particular use case, is it like write heavy, read heavy, what is the latency requirement, how you're going to partition it, like all of that is sort of like, the fundamentals are really important. And from there you kind of like, go about looking for like, different options available online, and like, comparing them. And I don't think you can choose to be an expert in certain like, tools. So for example, you can choose to be expert in like say Flink or Spark or a certain database. But yeah, I wouldn't imagine like anybody to be like, have the whole breadth of knowledge as well as, expertise in like, everything. And that's kind of like, I guess, sort of impossible.
In terms of the team that you're working with, what are some of the ways that you as a group lean on each other to accommodate the knowledge gaps and understanding that each of you have, and ways that you're able to work together to be able to understand the entire breadth of the problem space and help level each other up, particularly if somebody's coming in where they say, I got hired on because I'm an expert in Spark, but now we're dealing with Iceberg tables, or now we're dealing with Flink stream processing, and I'm way out of my depth here.
We definitely lean on each other for that sort of like, help. We also have like, like we're lucky to have dedicated like, platform teams who are like, experts on certain things, and their literally job is to have a eye on the market and keep evaluating what new technologies are out there. And then they also kind of bring up reports where they evaluate something which is like out there and say, oh, this is think this is something good, and we can think about adopting this technology sort of internally. Otherwise, or whether they think that this might not suit our company so more. So it's actually I'm very lucky to have that resource. So they do the first line of groundwork for us when we are sort of evaluating if we need to go after something else. Can lean on them, get their expertise. If we do not agree with them, or if we feel like our use case is very niche, then we can also kind of put forward a counter argument that, hey, I think this works for us and this suits us. So as long as you have enough good arguments, enough data points, backing your use case, you can just go and use anything that you want over here.
And then, particularly along the axis of reliability, observability, data quality management, when you are building custom components or extensions to some of those off the shelf frameworks, what are some of the principles or core libraries that you've developed to be able to manage the visibility into those custom implementations so that you don't lose context or lose visibility into the overall flow and quality of information that you're processing?
Oh, this is interesting. So I think observability and reliability is still sort of, I would say, a little bit solved problem. But I think data quality is something which is sort of there's not straightforward solved answer. We have a lot of custom tooling, but to be honest, I don't think so we have something comprehensive which is taking care of everything. We have bunch of different tools which are discrete, and they're doing they are pretty good at one particular stuff, and we have to kind of use combination of everything to make sure, okay, the data quality is fine. So that's an interesting and unsolved space for us right now. And for example, in data quality, I feel like we have solved schema issues. You can have schema whatever checkers and registries and all of that. All of that is working fine. We have volume based auditing and everything that also works pretty well for us. You can gauge it if something is not going as it is supposed to be. But one thing that missing in our tooling is semantic, I guess, semantic auditing. So, for example, if some event happens and you log something, your logged output might be correct according to schema. The volume might be correct according to what the trends we are seeing, but maybe you have logged the wrong thing. And there's not a really good way on how to actually catch those sort of errors.
Another element of data observability is that it will also typically be at least somewhat correlated with observability of the operational infrastructure, where the data didn't get delivered because one of the nodes crashed and we have a split brain situation, or we lost quorum and so we're not able to actually move forward. And I'm wondering, what are some of the techniques that you have found helpful to be able to thread together that operational visibility, the operational characteristics of the underlying platforms, with the actual data observability and data quality management, to be able to more quickly understand what is the actual root cause, particularly when it's something operational and not a logical bug?
Operational bugs, at least at Netflix, are easier to detect. So, for example, if we have robust system workflow orchestrator, which is called Maestro. I think it's an open source product too. So if if something goes wrong, we automatically it kind of is integrated with our alerting system, PagerDuty. So you would automatically sort of get alerted that, hey, there is this workflow, there's something wrong. We it threw Spark error or something. Now, if you're not a direct, owner of the workflow, if you're like some sort of consumer, we have like different sort of alerts. We have a time to complete alert. So normally, like, we can set alerts. Oh, this workflow takes 3 hours to complete. But if it for some day it took 4 or 5 hours, so it just automatically like fires it, and it's we can easily go and upstream and sort of check of whether what happened in the entire processing pipeline. Was there some failure or something? Then we have alerts like freshness alerts. So we call it valid through timestamp, VTTS. So something like if whenever a data is written, audited, and sort of processed, we release a flag saying this data is correct till fresh and correct till this particular timestamp. So you can have those alerts too. So if we feel like, oh, this data has not been freshened up for a while, it's it's been like 5 hours, and we didn't get any fresh data from that particular source. So it automatically kind of like triggers another alert, and then it is routed to you can set it up like Slack, PagerDuty, or whatever, and just get automatically notified that there's something wrong over there, and you can go and investigate. So I would say like operationally, like it's like I think it's in a okay situation right now. We are also sort of trying some a little bit of self-resolving alerts, where if we feel a data we were supposed to receive suppose 10,000 records and we only received like 8,000, and there might be a late arriving data issue, then there are self-healing pipelines where like an auto backfill sort of like kicks off and automatically kind of backfills the data. So like sort of like slowly incorporating that. It's not like 100% there, but yeah, that's also one way of how we sort out operational issues.
And one of the aspects of operating large, high uptime systems is that they require automation to be able to actually sustain them. Whereas if you're running a smaller scale, you're running lower volumes of data, you can maybe get away with manual processes for error detection, error correction, and I'm curious what you see as lessons from working at these high uptime, high scale environment that are translatable to some of those smaller scales where you can say, oh, it's easy to automate this thing, so it just should just be part of the standard operating procedure no matter what your scale, and what are the aspects of large scale automation principles that don't translate as well to medium to small scale systems.
I know, like in smaller scale system, you can definitely get away with having a lot of like manual processes, like alerting, backfilling, or whatever. But I do think that it's important to keep these things in mind while you're designing this these kind of systems, because you never know when in a blink of eye from your small scale systems, you just end up in a in a place where you're suddenly getting much more events than you originally planned for. So, for example, I feel like even though we have a lot of things that are automated at Netflix, having a good alerting strategy is still painful. Like we either under alert or over alert. So, which both of them leads to their own set of like problems. So I think, like at least from in my experience, whenever I'm thinking of like designing a new data pipeline, I always kind of think about, okay, what are we measuring? What are the the who are my consumer? What's the impact? What should the alerting strategy be? I think that's a good, I would say, thing to do, even if you're starting with a smaller pipeline. Having having a good run book, even just for practice. Or something goes wrong. This is my run book. These are all the details over there. Do I need anything out of my outside of my run book if I need to solve this particular problem? And the answer should be no. Your run book should be complete. But that's a good exercise to see. Sounds easy, but I'll tell you, more often than not easy. So, but just getting in the habit, like, right from the very beginning, I think it would be like, useful thing to do.
And obviously, the topic that has taken everybody's attention for the past couple of years is AI and all of its various applications. As data engineers, there are, and software engineers and engineers working in technical systems, there are definitely ways that we can use generative AI to automate and accelerate our work. But there is also a challenge of being able to feed it the right context, feed it the right understanding about the problem that you're trying to solve. And I'm wondering how you're seeing that factored into the work that you're doing at Netflix, and in particular, given the size and complexity of the systems that you're operating, being able to feed enough of that architectural knowledge into the AI systems to be able to get them to give you useful outputs without just having to fight with it and go through an untold number of rounds of prompting.
To be honest, I would say that we have had like mixed results at Netflix. So, for example, like we do have a like internal version of like of search, which is kind of trained on our like on the internal documentation, because that bot has like sort of like overall view of documentation, so it's definitely doing better. We do have like we can like sort of as fun projects create our own Slack bot, train on our like support questions, or train it on our run book and help them to answer like questions. I think those have had mixed results, like not super great. Sometimes it's just like feels like there's more effort in like training the bot and making sure it's answering the right thing than just going and searching the answer by myself and answering it. So, but we definitely like use Gen AI tools, those bots for like developer productivity. We use it like we have use it for like auto completion or in notebooks, just to like prompt. I guess fancy autocomplete, and then we definitely do integrate it with our pull request to give like some sort of like suggestions on like code quality and all of that. I would say 6 out of 10 times it gives pretty okay comments. Otherwise, it's kind of like sometimes it just doesn't work. Other time, I think one other use case that's pretty good is like we kind of integrate it with like our build boards or like our workflow blog board. So if there is any error that happens, so it automatically kind of reads the log and bubbles it up, so you don't have to. And most of the time it does great, so saving clicks, I would say, instead of you going and like going through Spark and like or going through Jenkins and reading the logs and see okay what happened. It like bubbles it up, so that makes things faster. What else? Yeah, I think that's the, I guess, breadth of use cases we have right now for the for LLMs right now.
And as you have been building systems, working at Netflix, tackling the various data challenges that are faced by the scale at which you're operating, what are some of the ways that you foresee or would like to see some of the off the shelf technologies or some of the adopted best practices evolve to incorporate some more of this AI automation and intelligence into the actual processing layer to allow human operators to move even faster and not have to worry as much about the low level minutia of the bits and bytes and work at a higher level of problem solving?
I think, like maybe with things, if things get better with LLM, I think it could be like more helpful in like in the actual sort of like prompting for obviously like code completion, writing codes or something. Actually, let me take a step back. So when I'm designing this like any large scale system over here, I think the first step is actually designing the data model, coming up with it, the criteria of when that event is going to fire, how that event looks on like different clients, client devices, and all of that. I think for that, I don't know if there's a good way to sort of like get it solved by LLMs, but probably like it's just like needs so much context, and it's like going to be very difficult to provide all of that context to a bot and expect like great answers. It can be a good like starting step, but it's just there's so much work, so I don't envision any like it being useful in that aspect. But once we have like say a data contract or something, probably we could like be integrating it with these bots and sort of like generating code from that. Also like planning, it can little bit help on like planning on the architecture side. So, for example, if I need a Flink job and I could just feed it, okay, these are the like I'm expecting this much like volume, this much each event is going to be this size. Like, can you propose like what's the starting sort of cluster size I can like start up with to accommodate all of this. So probably if it could like getting all of this input like create like the first initial cluster for me, I think that would be great if I can just get to that point.
And another aspect of the ecosystem is that a lot of the tools that have become the widely adopted standards are getting to be old in technological terms, where they've been around for a decade plus. Spark, in particular, was built in response to Hadoop and the challenges that people were facing with Hadoop. There have been various generations of successive technologies that are taking aim at Spark and Flink. I'm wondering what you see as the forward looking viability of Spark and Flink as the primary contenders in the ecosystem now that there has been enough understanding of their characteristics, the benefits that they provide, and the shortcomings in terms of their technical architectures and some of the ways that newer systems are designed to address some of those challenges.
I don't think like I see something which is going to be a replacement for Spark or Flink as of now. I do think like there's a lot of things that needs to be better with Spark and Flink. For example, I think we just started auto scaling on Flink. I mean, I don't know about like the like what version it was released on, but I think we just started internally with auto scaling of Flink before. If any, I think this is one of the bigger problems that we have in the data engineering world, where like if we didn't have like systems that would automatically scale, unlike in software engineering, which is like it's kind of like stateless, and if something if there's more traffic, automatically you can set up like traffic guards or something, and then like auto scalers, and they scale it. For Flink job, we always had to manually scale it whenever we would get, oh, there's a lot of events coming in, consumer lag increasing. Even for stateless job we had to do it. So I think they started with that. I don't think so we have a solution for stateful jobs as of yet, so that's going to be an interesting problem to solve as things become more and more real time. You obviously don't want a human in there to be actually like operating your operating your cluster size, and these things can be taken care of. It'd be great. And also, for example, for Spark, even though we have like optimizations on Spark, it doesn't really actually work all the time. Also, like if there is something like hot partition or like skewness or something, it requires a lot of like manual, I would say, intervention. The regular parameters are not working, it just like fails, and then you have to sort of retune it and rerun it. So I think that is also another like bigger problem which has not been solved in Spark. So even though these technologies have been here for a long time, there's still a lot of like improvements that needs to happen, so that we can keep up with the with future, where like more and more real time data needs would arise.
And in your experience of working in this space of high volume, high speed data and high uptime requirements at Netflix, what are some of the most interesting or innovative or unexpected ways that you have seen either your team or adjacent teams address the design and implementation of solutions to those large scale data management problems?
This is interesting question. I think the first one that comes to my mind is it's in the impressions project, so it's just immediately screamed to my mind. So there was this use case of providing a year worth of impressions for certain models, and providing a year worth of person's impression is in real time is just an impossible ask, because I think one person would see around maybe 100,000 or even more impressions in a year is just like a really big ask. So we were thinking about the ways on how we could achieve that. Then it was the raw data, that was an impossible answer, getting that in real time and reasonable latency. So we were like, okay, what if we can aggregate it, what if we can reduce it somehow? So that's how we came to using something called as EMAs, just taking impressions and converting it to number using formula. So now from object we went to numbers, but still 1 year is, it's a lot. And also you gotta have some job which process 1 year of impression and converts it into numbers. So we came up with having a Spark job that would do this crunching and store it into Iceberg table. Now all is good and fine, we have data in Iceberg, but we cannot expose Iceberg to gRPC service and serve from there. We need something else, like an online data store from there. So this is the project I told you about, where we actually sort of we had to come up with a new technique of how we can take this entire gigantic universe of data and kind of sort of upload it into an online data store. So we sort of devised a clever technique where what we do is we upload this data sort of weekly, and then we have another sort of real time process which kind of service which takes these impressions, does some online crunching for a week, and takes week old data from this computed week old data and just combines it together and sort of provides real time 1 year worth of impressions. So I felt like that was an interesting use case, because normally we have used Spark only for analytics, serving analytics purposes, and it's after the fact. But this time we use Spark and Iceberg in the actual actual operational flow, and we kind of we are powering a use case in the in real time system like gRPC service, and we have this Spark and Iceberg in equation. So I felt like this was an interesting project, where you used both software engineering and data engineering and kind of combined together and built one product. I guess there are other examples too, just whatever really fulfills our requirement. We are always open for innovation and going beyond normal ways and getting that.
And in your work of operating in such a high demand environment and learning more about the various primitives involved in building these data systems and maintaining reliability, what are some of the most interesting or unexpected or challenging lessons that you learned personally?
I think, to be honest, I feel like at least in this world, technical problems are easier to solve. It's more just organizational problems that are harder to navigate, and that's been my lessons. So, for example, when you are dealing with impressions, now impressions are going to be created on client devices, and by client devices I mean it's going to be web or TV or your phones or something. So being generated over there. Now all of these client devices, they'll have their own limitations on how they can generate that event, whatever how much that particular client has logging facilities or whatever on the device, and how much it can capture, and whatever how much date capabilities the manufacturer is providing them. So all of these limitation kind of becomes really important to know when you are sort of designing an event, because now you have all of these constraints that you need to keep in mind, which which maybe earlier you didn't need to know. You just needed to know that this is my API, whatever. Now I need to know, okay, what are the constraints of their systems? Then what is their release cycle? What is their how are they testing their logging artifact? How are they doing canaries? How are they doing A/B testing? So all of that is it's just so much context required to do work in this space. So this is what which has been an interesting observation for me personally.
And as you continue to work in this space, invest in the reliability and capabilities of the data systems that you're responsible for, what are some of the lessons that you're looking to grow in, some of the resources that you rely on staying up to date and adding to your understanding of the space, and just general advice that you have for folks who want to be able to move into a similar position?
For me personally, I am really invested in learning, like, what's up with, like, data quality. Can we finally get, like, one solution that fits all and can solve most of my problems? So that is what I'm, like, personally invested in. Like I said, like currently my project is to go with the producers, sit and understand their use cases, like how they, what constraints they're operating in order to produce an event. How does the whole life cycle goes through? So I think this is a good exercise, and this is something I would encourage others also to do. Like, I don't know if it is just me, but I feel like, it's easier to understand how data is being used by consumer, whereas the producer aspect of it is sometimes becomes like, more black boxy. So like, just digging in over there and understanding what's happening in that world, and that could help with you, like, having better strategy for your, data quality. You don't have to, you can actually stop bad data from going in if you are more like, plugged in with how your consumers are doing their testing and their whole dev life cycle. So that would be one advice: be more plugged in with the data production process. And regarding how I keep up, I think I keep up with things normally as like any other folk in the field is keeping up, like, just like reading the tech blogs of other like, other companies, other newsletters, podcasts, and like, even like conferences, just like listening what's happening. I know there is like, some work going on data contract space. There was an open source project, so I'm curious, like, what that will lead to. Yeah, and there's like, some work which has been, I think LinkedIn has a open source sort of like data quality platforms. I'm following up over there too, and I'm seeing if that can be something that we can actually adopt and use for our use cases.
Are there any other aspects of the work that you're doing, the lessons that you've learned working on large scale data processing systems, or the predictions or wishes that you have for the future of data systems that we didn't discuss yet that you'd like to cover before we close out the show?
I think working in, small scale world as well as moving to like, large scale world, I think one thing has become clear with me is you need to definitely have good fundamentals. So I mean, in small scale world, probably you can, get away if you are not like, thinking about the architecture that much. You're not thinking about like, reliability that much, or, alerting or whatever. If there are like, inefficiencies, you can just cover up them with like, manually fixing things and all of that. But all of that really explodes when you go to a large scale system. Like if you don't think about the design carefully, even like, minutes of like, downtime can mean like millions of events are now gone and can have an impact. So like, it becomes very imperative when you are like, designing any system to think about all the challenges. Also like, not only like, about reliability, but also from cost standpoint, like, also think about that, like, okay, I'm going with this technology, like how much is it's gonna cost. Also like really negotiating about the amount of data that you need to have, that you need to store, is like, do you really need that data? Because all of this is again is going to cost you to, process, store. So all of these decisions just become really important as your scale kind of increases. That would be my advice. Like, don't forget the fundamentals, read designing data applications.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, definitely. I think I already talked about something. We need a better solution for data quality, or for semantical, like, answers for data quality. That's one. We need like, definitely, more reactive tooling for real time purposes. So like, I don't know, more autoscalers for Flink, stateful jobs, then definitely we need more sort of like, kind of investment in performance optimization for Spark, and like, less sort of manual tuning and manual feedback. And over there, I think that is like another unsolved space that we have for now.
All right. Well, thank you very much for taking the time today to join me and share your thoughts and experiences of working at Netflix and being responsible for high speed, high volume, and high uptime data systems. It's definitely a very interesting problem space to be working in, has a lot of valuable lessons to be learned from it. So thank you again for taking the time to share that with us. And I hope you enjoy the rest of your day.
Yeah, thank you so much. It was really nice talking with you, and yeah, we had a lot of like, great conversation. A lot of questions that I would also think about later in my day. Thank you so much for taking this.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.